Hello, let's continue our Sudoku adventure with Family Feud by MicroStudy. So this is what's called a chaos construction, which is an odd name, but basically it's an irregular Sudoku, but you have to discover the regions. So let's go over the rules carefully. So in every row and every column, we're still placing the digits 1 to 6 exactly once each. But there's also regions in the grid that, they're still of size 6, but they could be weird shapes. Like we could have something like this, right? Where purple is a region of size 6 and green is a region of size 6. We divide the grid completely into orthogonally connected regions of size 6, right? So this could be one. I'm not going to do the whole grid, but you get the idea. Within each of these regions, we are placing the digits 1 to 6 exactly once each as well. But we have to find where they are first. So that helps you find them. But anyway, we have just one additional rule, which is each of these given digits is in its own region. They're in a different region from all the other given digits. So, it would be tempting to make this a region, but that is not what the puzzle is. In fact, this is not allowed. These can't be in the same region. 1 can't be in the same region as any of these, and 3 can't be in the region. Yeah, you get the idea. So I feel like I'm spending too much time on those rules, given how simple they are, but just want to make sure it's clear. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. And I'm going to get started by picking colors for each of these regions. We'll use a distinct color for each region and go from there. So each region is 6 in size, right? So there's this idea of regions having to get out, right? Because they have to be orthogonally connected. So this purple needs to be 6 in size. It's 1 in size right now. So it gets out and has to grow. And there's only one, it has to grow, and there's only one direction it can grow because it has to be orthogonally connected. Can't grow diagonally. It has to grow again. So it's going to grow there. For now, from here, it has a choice. It could go down or right. Well, for now. But if we look at this red, it also has to grow. This red still has to grow, and there's still only one orthogonally connected cell that it can grow into. Now purple has to grow. We get to what I like to call a race, where they race each other, right? So 1, 2, 3, 4. This still has to grow. It can only grow here. It still has to grow and can only grow here. 1, 2, 3, 4, 5, 6. And now it's done. So what I'm going to do is I'm going to draw a black region around the completed region here. Red has to grow, so it's going to grow down. And now it has a choice of these two. Blue has to grow down. There's a lot of things you're probably seeing, but I'm just kind of doing them as I can. Green's going to have to grow twice. Orange is going to have to grow twice. Yellow's now going to have to grow twice. This is always fun. So 1, 2, 3, 4, 5. But if green grew to the right, basically what we can say is orange has to grow, and it still has to grow again. So now green ends up being just this complete column here, and then orange has to grow, and I believe orange is done now. So orange is like this. Yellow has to grow, and now blue has to grow, and now red has to grow. Red has to grow again. 1, 2, 3, 4, 5, 6, yeah. So now red is done. Blue has to grow. Yellow has to grow and grow again. 1, 2, 3, 4, 5, 6, and then blue takes the remaining. So that is our regions. And so now we have an irregular Sudoku, and we just solve it. Just solve it. So 1 needs to go in purple somewhere, and it can't go in the top row, so it's going to go there. It needs to go in red somewhere, so it goes there. It needs to go in blue somewhere, so it goes there. It needs to go in yellow somewhere, so it goes there. And there should be one more. This bottom row needs a 1, and orange needs a 1. There we go. 2 needs to go in orange, so it goes there. I wonder if I can solve these in order. 2 needs to go in yellow, so it goes there. This is kind of a mirror of what happened to 1s. 2, 2 is not in any of those, so it goes there. 2 is not here or here. So 2 could be in either. Oh, no, 2 C's up there. Never mind. So 2 goes there, and then we need a 2 in this row, which goes in green. Let's do 3s now. 3 goes there in red. It goes there in blue. This 3 C's here, this 3 C's here, so 3 goes there in yellow. Green needs a 3, which goes there, and then purple needs a 3, which goes there. All right, 3s are done. 4s, 4 goes there in yellow, goes there in blue. We can tell you that that's a 5 and that's a 6 if we want. Oh, but no, I want to do them in order. Hold on. 4. These two 4s look up, putting 4 here, and then green needs a 4, which is going to go there. I wonder if green's going to be 1, 2, 3, 4, 5, 6. 4s are not done. What 4 am I missing? I'm missing this 4 there. Okay. Now we do 5s, of course. So yeah, 5 is the last digit in blue. 5 in purple now can only go there, and red can only go there. So 1, 2, 3. So we need a 5 here for this row. We need a 5 here, and then the remaining cells are 6 along the diagonal. Nice. Cool puzzle MicroStudy. It was basically a pencil puzzle in disguise, because once we got the regions done, it solved quickly, but we didn't have to use the numbers for the regions. But that was fun. I always enjoy the chaos construction logic of growing the regions. It's usually the more fun part anyway. And we did end up with 1 through 6 on the left column and on the top row. So nice there. In fact, it's 1 through 6, then 2 through 6, 1, then 3. It's completely rotated. That's fun. I just noticed that pattern. Yeah. Cool. Well, thanks for the puzzle again. I hope you enjoyed it. I certainly did. And if you did, then why not leave a like, subscribe, and a kind comment below.